The next thing I want to take a look at is that I can group things. We kind of talked about that in that beginning part. Apply order of operations and inverse to solve our equations. So when I am looking at this, the distributive property is a mathematical property used to simplify equations and expressions, and what we're really trying to do is eliminate the parentheses. That's what distributive property does. It distributes, just like I just distributed out your workbooks, right? I went down each row, handed those out. We're eliminating those parentheses. I'm just getting things out to you, right? Term is part of an expression usually separated by addition or subtraction signs. So if I'm looking up how many terms in this expression right here that I'm underlining, 6x plus 21, how many terms? How many terms? Separated by the addition sign, we have 2 terms, right? Please write that right behind. 2 terms. Okay? So we have 2 terms there. If we are looking at this expression, 5x squared plus 3xy minus 2xy plus 19, how many terms?
4.
4 terms, right? Please write that right behind. I have 4 terms. This number 19 and this number 21, those are special numbers. 19 and 21, and anytime you have a number by itself, it's called the constant. So a lot of times I might say, well, what's your constant in your expression? Constant just means, what's the number? What's the number that's all by itself? That's called our constant, okay? So terms are separated. These 2 terms right here, those are considered my like terms. I have xy, same variables, same powers. Those are considered my like terms. Like terms we get to add together or subtract. That's nice. And the coefficient. Coefficient is a term, is the number that is being multiplied by the variable. Not all terms have coefficients written in front of them. If there's no coefficient, it is understood to be a 1. That means this. If I have x, that really means it's 1x. Anytime there's just an x or a y or any variable, it's understood to be a 1. If I asked you in this problem, what is the coefficient, please write this down, coefficient of x squared. What's the coefficient of x squared? 5, right? So it just means the number that's times it, right? xy has 2 coefficients. xy, so if I asked you for the coefficient of xy, the first one is 3. The second one is the one where people will get wrong. Anyone want to try me and see if they can get it right instead of wrong? You think you got it, Jeff? -2. It is -2. Way to prove me wrong. It is -2. You have to keep the sign with the coefficient, okay? So it's not just 2, it's -2, okay? So whenever you talk about the coefficient, you must keep the sign with it, okay? So anytime I'm talking about my coefficient, it has the sign with it, okay? That next page, you're looking at your notes. We want to distribute, okay? So you did this last year, right? I want you to show, as you're doing this assignment, these arrows. Someone said, do I have to do this for the whole unit? No, once you show me that you really have it down, I'm not going to be that concerned. But for this first one, I want the arrows. What do the arrows tell me? The arrow tells me you're taking 2 times y plus 2 times 4. Don't use the x for times, either use a dot or use parentheses, okay? So my final answer would be 2y plus 8. If I was looking for the number of terms, how many terms? 2. Coefficient of y is what? 2. Constant. Constant. Do we have a constant in this one? Yeah. It is the 8. Is that making sense to everyone? Thanks, Anisha. As we start this next one, put this arrow. This is telling me that I'm taking 12 times each thing. I'm taking 12 times 3. So sometimes I'll use a dot, sometimes a parenthesis. That's nice. It's 36, right? I have this minus sign. Because I have a minus here, I'm going to keep this as a minus. I'm going to take the 12. I'm going to write that down because I'm distributing it. 1/6 H. You guys kind of remembering this from last year? This is 12 over 1. So, Cole, if I'm simplifying 1/6 and 12 over 1, what number goes into both 12 and 6?
3.
Bigger.
6.
6. 6 goes into 6 once, and into 12 how many times? 2. So I now have 2 times 1 times H over 1, which is just going to be 2H. If I was looking for the terms, Andrew, how many terms in this answer?
2.
2. Someone said earlier, oh, anytime you have subtraction, change it to plus or negative. I would take this answer either one of these 2 ways. Okay? And the thing about about writing it this way is if I ask you for the coefficient, Traylon, the coefficient of H, what would it be? Careful, right here in front of it. And we would have to say -2, right? So watching that, so the reason that I agreed changing it to maybe plus and negative is that helps you to pick out and not get it wrong that it's a -2H. Constant would have been 36 if we were looking at it, right? I want you to try these next 2 on your own. This time the 3 is behind, does that matter? Still distributed. So show your work, 3 times the 0.4. Write this down, do the problem on your paper. Do the next one also, where you're distributing the 1/5. Okay? Do them both.
1.2 plus 3.3 Z.
Yes. If I was looking, Micah, at how many terms there were? 2 terms, right? All right, next one. You ready?
Not yet.
Okay. Tell me what I'm going to start to write down. 1/5 times what?
5 over 1.
5x over 1. You want to simplify it for us?
It also
Then?
equals 1x.
It does equal 1x. Then I'm going to have minus, and tell me what to write, Gus. Cole started us off, or not Cole, sorry. Sam started us. He said take 1/5 times the 5x. Now what do I have to do? I put the same minus sign. So 15, and I want to go with the 1/5 times that. And I want to think of it as 15 over 1, right? So, Brooke, if I'm looking at that, how can I say? 3, and this is going to become a 1. 5 goes into 5 once and into 15 3 times. Right? If I ask, what is my constant in this one? Lily, what's my constant in this answer? 3. So sometimes people, like I said earlier, changing that subtraction so that you see 1x plus -3, so the constant should be -3, okay? If I ask for the coefficient, so I would take this answer or I take this answer. I would also take this answer, x minus 3 or x plus a -3. If I'm looking for the coefficient, Jack, what's my coefficient of x?
Coefficient of x is 1.
Coefficient of x does equal 1. Is that making sense to everyone? So putting that down, yes.
Why did you have to do 5x
Because a lot of times people will see this as 5 over 5. It's the same as 1. But we're not taking 1/5 times 5. And when you multiply that, you do get 1. But sometimes I'll have people take 5 times 5 and get 120 there. You don't have to put it over 1. But if you write it as a fraction, then some people go, oh yeah, that's how I get 1, because 5x over 5. You wouldn't have to. Right? Okay. All right, let's go to the next page in your notes. And if you are reading, please, Jack? Would you read what it says to simplify?
Simplify each expression, divide every term on top by the number on bottom.
All right, so Nathaniel, start me out. I'm going to put 3x over what? What's in the denominator? 5. Then I'm going to put a plus. And then, Chloe, I'm going to put 10 over 5. And if you can simplify, you do. Which in this case, 3x over 5 can't be simplified, right? That stays as 3x over 5, or 3/5 x. But, Emily, I can simplify 10 divided by 5 is 2 over 1, or I can just write it as 2. So 3/5 x plus 2. 3/5 x is the same as 3x over 5. Does that make sense to everyone? 3/5 times x is the same as 3x over 5. Okay? So you can think of it either way. All right, so we're going to keep going, Kaden. Got to do that same thing. Right, divide each one top number by the bottom. So I'm going to write down what? 15? Just divided by 7. Okay, keep going. Plus
6 and 7.
yes. Can I simplify either of those? No, that's it. We're done. Okay. Tanisha, would you read that part about multiplication?
Any number except 0 multiplied by -1 will become the opposite of that number.
Examples. Keep going.
Examples: -1 multiplied by -5 is 5. Or -1 multiplied by 6 is -6. Or -1 multiplied by 0 is 0.
So this is the only one where you get 0, right? 0 times anything is always, always, always 0. Okay? So, Urban, we're going to show this first one with distributive property, right? Okay? You're going to help me out. The next one we're going to show with just taking the opposites, because there's a negative in front. So we're going to write down -1 times 2x. Then I have a plus, and I'm going to take -1 times y. And if I think about that, the opposite of 2x, treasure, is? Opposite of 2x is? Opposite. Negative 2x. Keep writing, Katie. And the opposite of y is? You still got the, or is going to be a negative y or -1y. Someone said, could I have just written this answer as -2x minus y? Same thing? Yeah. 2 terms. Coefficient of x is what? Which one? 2 or -2? -2. Coefficient of y? -1, thanks, Amy. So this one, we're going to think of this negative out in front as just telling us to take the opposite of each thing. Because that's really what the negative does. A lot of times I will recommend that you write this when you're doing the problems as -1 times -3 minus 4u. But it says anything you take times -1 becomes the opposite. So the opposite of -3 is going to be what, Emma? 3. And then I'm taking the opposite, right? The opposite of negative for u, because we do want to think of this as plus and that being the negative for u. So the opposite of negative for u, Emma, would also be positive for u. Everything changed to the opposite when you multiply by -1, okay? So anytime there's a negative times anything, it changes it to the opposite. All right, so. Didn't need to do that. All right, so let's go back here. So combining like, oh no, we got to read that part before that. So, Chastity, you ready to read first? Like terms, please.
Like terms are terms whose variables and their exponents are the same. In other words, terms that are like each other. Note the coefficient, the number you multiply by, such as 5 and 5x, can be different.
So, different coefficients, but the xy squared is the same all the way across. So these are all like terms, they have that xy squared. Unlike terms, if we are looking negative 3xy, negative 3y, this is y to the first, 12y squared. They are unlike because the variable powers are different. So unlike terms cannot be added if they have different variable terms, only like terms. So it says only like terms can be added and subtracted, top of the next page. In order to do this, identify your coefficients. So we're going to add or subtract those coefficients. The variable part does not change. I know some of you already had your answers, which is fine, but I want you to still write in your notes this part that I'm writing down. I'm okay that you already got the answer for that. I just want you to write down that we're adding 3 plus 8 plus what's my last coefficient? 1. And all of that is with the x, right? So 3 plus 8 plus 1 does give us 12, and then we're going to write x. We don't make it an x squared. It says the variable part does not change. So, again, if I was showing my work, I'm taking those coefficients, I'm taking 5 and subtracting 2, and I'm going to have an m with it. So I'm going to have 3m. Jamie, you ready? 5x squared plus 7x squared. We're going to do that addition, right? A 5 plus 7 gives us what? 12x squared. Mara, you ready for that next one? What do you got? Yep, how much did you end up with? 4. Jaden, the next one, we'll start subtracting. Negative 9 plus 6.
I added the 6 and 5 first.
Okay, 6 and 5. Can we do that? Is that okay if we had 6 and 5 first? Yep, so 11. Okay.
And then I added the negatives to get negative 11 and positive 11 to get 0 AB.
0 AB. If you put down 0 AB for me, I have to mark that wrong.
0.
Because anything times 0, if you're simplifying, is 0. And I'm okay that you put this first, but I'll have people put this as just AB. And they don't like to put the 0 down. Well, this is like a 1 AB, right? That's not the same as 0, and this is 0, okay? So just being really sure as you look at that, okay? And is it okay to add things out of order? Yeah, that's what the commutative property and addition, it's a wonderful thing. Regrouping things, but you got to just be careful for the signs when you're doing that, okay? All right, so top the next page. Please do the first 2 on your own. We're going to look at that third one with the distributive. I'm not going to check it till next week. Okay, so you ready? What'd you get? 2y. Next one, Aiden, going across. What'd you get? Negative 12m and the 4th. Everyone okay with that? Making sense? Okay. Here we have to distribute first. This is like what we did at the beginning, right? So Ian, start me off if we are distributing. What would I have when I distribute that? Okay. 3 times what? Okay, first time's the first one. Remember my first arrow? So I'm going to go 3 times x squared, okay? Then I'm going to do what? Oh, you know what? Your mistake, I know you hate, I know all of you hate when you make mistakes, and I would say that when you're doing that C stuff, if you make a mistake and you can find your mistake, your brain really does grow when you're doing that. So thank you for doing that, because now hopefully everyone in this class won't make that mistake, right? So he said just put plus 2, but what do we have to do? We need to take 3, that arrow, and we got to take 3 times that 2, right? And then we have this 2x squared. So if I'm looking at this problem, the most common mistake that I'll have people do is they'll put 3x squared plus 2. And it should be 3x squared plus 6 plus 2x squared. All right, so Cole, like terms, which ones look alike in that expression?
3x squared plus
So I will sometimes, even in my homework, if you're doing the problems, I might even circle what looks alike, right? So I circle those two. Now I'm going to add those coefficients. So Andrew, when I add the coefficients, what do I end up with?
5x squared
5x squared plus
plus
6. Last one. Anyone want to volunteer and tell me what I get for the last one when I add them together? Micah, you got it?
Well, since you can't add them together because one is 3 to the second.
Yeah.
Done to the second. And the other one
You
is
can't
the
add it. It's impossible. Can't be simplified, right? It is simplified. I take an answer like that in simplest form. Can't be simplified. That problem does not have the same. Nice job picking that out. One was to the first power, the other one, if we were looking at it. And if there's no number written in, remember that is a first power. Okay? So they have to be exactly the same. So, this is like we did at the first part. Write the fraction over each individual one. Take a look at your notes if you need to. The negative one, and then adding the like terms at the bottom. Okay?